So now let's look at the last concept, which is going to be concept number 7. And it's going to be now the differentiation of parametric functions, or we can say parametric differentiation. Okay, what is a parametric function? Parametric function, these are special curves. Okay, when you plot them, you actually get a curve, whatever shape it could be. There could be many types, but it kind of bends like that. So we could represent it as a parametric function, this curve. In other words, this is how it shows it. You can have the curve, you can have a curve, you can have it as, you'd say, for example, here's an example of a nice one. You'd say x is equal to 1 plus 3 sine theta, and y is equal to 3 tan theta. Okay, and here they are saying 4 pi over 2 less than 0, okay, which is less than 3 pi over 2. Okay, again, less than theta, not 0, okay, which is less than 3 pi over 2. So they could give you a range, and then you could need to use that range for anything. But if they say, if the commandment says find dy dx, okay, find dy dx in terms of the parameter, theta. So what makes this explicit is you'll be having two separate equations for your y and your x. Okay, you'll be having them as two separate equations. Now, when you want to get them together, you just use the chain rule, and this is the easiest thing ever. So you can say x is equal to 1 plus 3 sine theta, which means dx d theta, derivative of x with respect to theta. Okay, dx d theta is going to be the derivative of 1 is 0, derivative of 3 sine theta, 3 is just a number, it will be outside, derivative of sine is cos, so it will be 3 cos theta. Then here we have it as y is equal to 3 tan theta. Okay, we can now say dy d theta, dy d theta, it is going to be the derivative of, it's going to be 3 is just outside, derivative of tan is sec squared theta. Okay, and then now we have it. So we can now say by chain rule, now we can now say that dy dx is equal to dy d theta times dx times the d theta dx, okay, or times, sorry, dx, it will be times d theta dx. And here, look at where the nice thing is. I have dx d theta, but I need d theta dx. Okay, I need d theta dx. So here I have dx d theta. So I can say this is the most important part which I had left, is to say d theta dx will be just 1 over 3 cos phi. Okay. Okay, so you flip the left to become d theta dx. It is equal to, you flip this, it becomes 1 over 3 cos theta, which is going to be, what's my dy d theta? 3 sec squared theta times, what's my d theta dx? 1 over 3 cos theta. Okay, which is going to be here to be 3 sec squared times 1 just becomes 3 sec squared theta over 3 cos theta. Okay, so remember, this is the stage which you need to be careful, is to change your dx d theta to your d theta dx. Okay, unfortunately it will be code, so it's going to be 3 and 3 cancel, you remain with sec squared theta over cos theta. And this is going to be your final solution, and you have it and you are done. Okay, bye bye.